Okay, so may I have your attention, please? Okay, so thank you. So hi, my name is Michał Różycki. It's nice to have you here at DevOps Days at Warsaw. Fun fact number one, the DevOps term was introduced like 10 years ago, almost 10 years ago, at the first DevOps Days in Belgium. I'm not sure if you are aware of that. But in this DevOps term, it clearly shows the connection between developers and the operators teams, right? And it works, this connection works perfectly. And in my opinion, it can work even better if it involved with security. So this is when the DevSecOps term is introduced, right? I'm not sure if you heard about this, probably yes. And in general, in simple, it just says that everyone is responsible for security. Not only the security, but also it should be responsibility for developers and the operators. And this is why I would like to talk about security today. But if you can see, there's also a container in the subtitle, right? And why container? Because I like containers. I like containers because I'm a developer. I'm a developer and I have like huge 6 years of experience. And in this huge 6 years of experience, I've touched a lot of technologies, and I was working with a lot of clients. And there was also always a problem when something was working on my machine, it doesn't work on machine from my clients or everyone else. So this was the one problem, and this problem is solved by containers. And maybe put hands up who don't. Is there anyone who doesn't know what the container is? Okay, so probably I can skip this slide. So, but in general, it's just a standardized unit of code and the dependencies. It's the best benefit is just much smaller than virtual machines, right? It gives you the ability to run fast, and it gives you this confidence that it's reliable and consistent in every platform. And if it runs on your machine, it runs on our machine. But there are problems with that, because if we think like the containers, they are small, right? We can run plenty of them on our host machine, and in some case, there might be a situation when one of the container, it takes all the resources, and all the others are just stopped or paused because they are leaking they have the denial of service, right? They cannot get the service, this resource they want. The another threat they comes out from the container is the problem that if it shares the operating system with the host it runs, right? So there might be a situation that some malicious code in your container may break out from the container and take some actions on the host machine. Let's say from the other side, the kernel exploits, some kernel vulnerabilities may affect your container. And the problem with some malicious code in the container is that the container itself doesn't provide the authenticity. So you don't really know if it's the real one. You cannot answer the question with simple container. If it's the real one, I just download it. Is it modified or not? So at the beginning, the containers were wow, right? Just run them, just use them. But with those security concerns, there are some concerns, right? So you have to think, and luckily, there is some tool that helps to solve some of the problems that I've just showed before. So there is the update framework. The update framework, as the name says, is the framework. It's focused on the update systems. And it states that the secure system, secure update system, is when it knows about the new updates quickly, the downloaded files are correct, and there is no harm from checking the files or downloading them. And to achieve those three goals, the update framework, they've created the 4 principles. The first one is the responsibility separation. It gives you it simply says that there is no one role in whole, let's say, organizational whole group of people that take one action. You should separate those actions and create some different roles for different people. And it allows you to, for example, that if some role, some attacker will attack one of the role, it can only get access to some part of your, let's say, whole system, right? Or some layer, not the whole system is taken, right? The next one is the multi-signature trust. It just simply says that you need 2 or more, the multi-keys, to take some action. So like, it's like you take 2 keys to unseal the data, or 2 keys to, or maybe more, to protect to validate some data. The next one is the explicit and implicit revocation. The explicit revocation says that you need you need the mechanism that allows you to get, let's say, some parties and explicitly revoke some keys for other parties in the company. And implicit is like you need some, let's say, automatic auto-rotating keys mechanism, and it should be used, for example, by the server when the time living of the certificate is done. So you need to re-rotate the key. And the last one is the principle is to minimize the risk. And the risk, it can be just calculated from the, let's say, possibility that your key or your certificate will be taken, will be stolen, and the damage it can make. So it's the main idea here is like, if you have the, let's say, the most important key in your company, you should keep it very safe. They are even saying that you should print it and put in the bank vault. That's the best way of keeping it secure. So with those principles, let's say the whole world of IT world, they made a lot of adoptions of the update framework. And you can see in the right corner that there is a Docker, and how Docker uses this update framework. There is some part of the Docker engine called Content Trust, and this one is, in fact, it's not really using the update framework right away. It uses the Notary. The Notary is a tool written by Docker, and it's the tool that it's an opinionated implementation of the update framework. It's open sourced, and it gives you the easy management. It's an easy management tool for managing those keys and so on. Because the update framework, the main idea of the update framework is to create some different kinds of metadata and store it on the server. And this metadata can give you the guarantee about the integrity of the system. And in this case, you need some tool you can do it manually, manage and upload and so on, all those metadata, but it's better to have some tool, and the Notary is some kind of this tool. And what are some of the features it has? So if it's based on the update framework, it should, fulfill those 4 principles. So one of these is this separation. And here in Notary, we've got 4 or maybe 5 different roles. And in each role, we've got, let's say, linked with this role, we have some key and some metadata. So from the top, the root role is the main role that it uses its key, the root key, to sign the root metadata, right? And root metadata just describes all these other keys and all the different roles that is used in this secure system. And this key is the most important one, because if it gets stolen, it's problematic. You can define some other targets keys and so on, snapshot keys, and In fact, if you don't have like some copy or something like that of this root key, or you don't have the multiple trust here, then you're probably fucked up. Next, you've got the lower layer. Let's say you've got timestamp, snapshot, and target key. The timestamp gives you the information about, it provides the metadata, and in this metadata is signed by timestamp key, right? And this metadata provides you the information that it guarantees the freshness of the update, that this is the latest one. The snapshot, it gives you the information about all these other metadata stored in the server. So it's just giving you the information that you guarantees you the integrity of all those metadatas created by the update framework. And the targets key and the delegation key, they are pretty the same, let's say in a role. The delegations key is like some subset of targets key, because it's focused on this image, the content itself. It provides the metadata about the content you are signing and you are pushing to your repository, right? And the delegation is you can create some delegation to just some part of the whole system to give to your, let's say, some another team that is focused on some other part of your system. And another thing in the Notary, the architecture, how it's built. So we've got two main components. We've got server and the signer. Server is like, it takes, let's say, most of the work. It takes the metadata served by clients. It's stored in the dedicated server. And the signer. Signer keeps the keys, those let's say those snapshot keys and timestamp keys, for example, and it's used to sign all the data the server wants. So this is the separation here is done for to provide a bit more secure system, because if someone just breaks into the server, he has to break also into the signer at this point to get those keys, right? And on the other hand, we've got the clients, the API client, some client, Notary client. It allows you to easily list the metadata, list the keys, and check the whole system and easily manage the whole system. And that's the theory. So maybe let's bring up some demo and show you how it, how it works. So about the demo, maybe just before I jump there. So what I've got here, maybe I will show. So I've got one repository, good repository. It's the Docker registry, right? It's deployed on my Minikube. So you can see here the pod with registry and some service. And this is a node port, so I've created here some local variable, the environment variable that points just to this Minikube registry. So what I want to do, on this registry I've got few images. So the whole plan will be like, I will just made some basic stuff with the Docker images. So let's just curl this image to check what's there. So we can see here we've got the hello repository, right? So if we just list the tags, I can see we've got 3 versions of the hello application. So maybe just run the first version, and check if it works. Okay, so everything works, right? We've got hello DevOps days, and what's next? Because I was saying about this Docker Content Trust. In fact, this is already there in the Docker. You just need to enable it by setting Docker Content Trust flag. And in my case, I need also to create Docker Content Trust server, because let's say I'm using my local Notary server, because this Docker Content Trust server is just it points to the Notary server endpoint. So in my case, the Notary server is just some local host 4443. And if you can see on my third tab, I've got this Notary server running. It just to run it, it's just a simple Docker Compose app method, and it downloads all the files. I've made it beforehand because it takes some time. So what we've got this Docker repository, it works. We've got this Notary server, it works. And now I've just enabled the Docker Content Trust. And what's next? The next is just try the same. Try to run this previous image, and what happens? It cannot be because this there is no remote data. There is no metadata for this hello version 1 file on this localhost 443, right? The information is clear that you don't have trust data, so you cannot run it. So big plus, because you don't run some untrusted image. So what's next? Let's use Docker tag and create from this hello version 1, and this is just a demonstration how it can be done. In production, it shouldn't be this way, but you just create, let's say you create a new version with the file, with this hello application, and during the push, when you want to push it to the repository, you can see there is a huge information about it's getting the signing and pushing trust metadata, right? And to make this signing appear available, and you need to create those root key and the targets key, right? The Notary server, this is the whole job of the Notary and the update framework, right? It creates the keys for you, and then it creates those metadatas, it signs the metadata. So, and let's put some dummy password for the root key, and the dummy password for the repository. And now, boom, we've got finished initializing this hello, and so it's successfully signed. So if at this point I will run it again, for example, maybe let's check this version 1. Still, no valid trust data for this one, right? For version 2, it works, because when we were pushing this, we also, the Notary, it created the metadata, and it signed all this metadata and all this image, and it's on the one hand we've got this image on a repository, and the other hand there is a Notary server, and it has corresponding metadata to this version, and we can list this metadata or this information. So what we can do, we can just use this Notary client using the list method. Just provide the name, and what can be seen here is like maybe just a little. Oh, okay, we can see here that we've got version 2, right? Yeah, you can see that, and we've got some digest here. So it says that we've got some information about this file, and what's next? We can also list the keys that were created. So we can see here, or maybe I will just make it a bit smaller. No useful. Okay, so in general, we've got you can see here, we've got the root role and the targets role. Those are the two roles created by the Notary, and it's stored locally in this trust, in this user's Miro Docker Trust private location. There are stored the keys for this root and the targets. The snapshot and the timestamp, they are managed by the Notary itself. So you don't need to create and manage those keys and those metadata. So maybe I will also show you, show you this, what's here, or maybe, okay, let's copy some files from this Docker Trust, and here we've got stuff. Here is, this is a local copy of the metadata that was created by the TAF, this update framework, and the Notary, right? So here we've got the, let's say, the name of our package, and we can here we can see the metadata. We can see, let's say, I will look at the root JSON. Let's copy it here to my folder, and here also let's copy first the targets JSON and okay here. So now let's move to the, let's say maybe I will bring it a bit. Give me a second. Okay. Yeah. So this is the root metadata. It was generated, and you can see we've got here some keys, right? And below that we've got some roles, and all this stuff was generated before when the first push was done, right? And you can see some of those keys are, in fact, let's see, this one, it's the same. It's the definition is here, right? And what about the targets? The targets is just, it just shows the version of the file and the length of the file, right? This is the information about the targets, and this is the, let's say, the checksum, the hash for our version, the image we just signed. So this is how the metadata looks like. We've listed some keys, and what's next? Because this looks pretty easy. In fact, you can see that there is no additional work besides this just providing the passwords. There's no additional work from, let's say, developer from our perspective when you are using the Docker command line, right? Because you are using Docker pull, Docker push, and so on, and everything works fine. But right now, we've got also always the happy path. Let's check for the next one. Let's check if it works also for some, let's say, problematic case. When, let's say, simulate some attacker. So what we are going to do. So let me just run this version. Okay. So let's disable the Docker content trust. Content trust for a moment, and yeah, we can run this to show that it still works, right? So we've disabled it, and now what I'm going to do, because I've made a bit small because beside this, next to this good registry, I've got also the bad registry. I've got the bad registry, and here there is no service. So what I'm going to do, it's just a silly method to simulate the attacker. He's moving the, let's say, the endpoint from some DNS from your repository to his own repository. So what I'm going to do, I'm using the kubectl edit method. I'm not sure if you are aware with the Kubernetes, but let's see. Yes. What I'm going to do, I'm just editing the service. It's a node port, and it's pointing to good registry. I will point it to bad registry, right? So from now on, I got the bad registry that my previous Docker registry was. From my perspective, let's say from developer, I cannot see, nothing has changed, right? So I'm living in my perfect world, and I'm trying to do my stuff, and what I'm going to do, and I'm just, let's check what's the catalog here, right? Or maybe just first this one, and what are the tags here, all right? So we can see, yeah, the repository seems to be pretty the same, nothing has changed, but if we take a look for just the catalog, yeah, we can see this is not exactly the same repository, right? We've got some hacker stuff here, or hello is the next to this one. And if we would like to run this one, no, because we've got it in a cache, so let's remove it. For example, so we remove the image, for example, and run it again. And we can see this is not the message we are expecting, right? We've got them here. We run the Docker hello version 2. And we've got the message, my name is Potato. This is not the right message, right? So we were obviously hacked, and this is because we are not using the Docker Content Trust. And what will happen if we, let's say, export, Docker Content Trust to 1. So at this point, let's try with running the version. First, let's try with version 3. So there was also this version 3, right? Version 3. Docker run. And here, we've got still the same message. There is no valid trust data for version 2. So version 3. So yeah, it works. But what with this version 2? Because previous, if you can see, Docker images shows that we've got the version 2, version 1, right? The version 3 wasn't even downloaded because it was blocked by Notary, that is content trust. But the version 2 is still there. So what will happen if we run it again? Previously, as you remember, we got this message, my name is Potato, from this one. And we've enabled Docker Content Trust. We got here the Hello DevOps Day folks message. So this is some strange thing, because why it's happening? We can even, delete the hello. Give me a second. Okay. This one. Nope. Docker images. Okay. So what I'm going to do? So let's maybe container list. No. So let me just remove the container first, and then here this container Docker RM. Okay. Okay. So again, let's remove this image. Okay, it's deleted, right? And what will happen if we run it again, right? Remember that the dir variable is pointing to this bad registry, right? But thanks to the Notary, it runs the correct one, because the Notary knows the correct one. It has it in cache, the correct information about the valid image. So even if you would like, let's say your attacker would like to, in the middle, just change the packages and so on, you are still secure, because it runs the correct image. So this is all for the demo. And in fact, it sounds like the valid solution, but it's the valid solution just for only one, let's say, part of the threads. And the next part is the list is still long, but still, for each thread, we have each tool that can simply try to solve it. So for example, there are some vulnerability scanners. Claire or Anchor, it's just scan your images with some known with some database in the background with some known vulnerabilities, and just check if these images you have in your registry, they are safe or not, if there are some known exploits and so on. The next, there are some firewalls or some activity monitors that they are running in the, let's say they are working in a running system, in the running container, and checking if there is some strange behavior from the container. And there are also a lot of best practices for secure Docker images you should check. And that's all for today. Do you have any questions? Yeah. So you've got the bad image, right? And you want to push it to the. Mm-hmm.
But the attacker switched the registry address or domain for the bad one.
Okay, so at this point, I've never checked it, but yeah. I think because no, it's like it won't. You will push to this repository, yes, but on the other hand, you will create the secure metadata for this image and store it on your Notary server, and then if you pull, you will pull, let's say the attacker will remove your package, your image from his repository and just swap it, right? And you think, okay, but there is the metadata for this. But if you pull it, and then Notary will see, okay, but this image I've just pulled, right? I've got the metadata for it, and it's not the correct one, right? Okay. Any other questions?
Is there any history of code breaking out from Docker containers? Are some kinds of those attacks are documented? Or?
Can you speak a bit louder?
Sorry.
Okay.
Is there a history of code breaking out from Docker containers? Were there such attacks documented? Have you heard anything about this?
About code breaking, like something breaks out of the container. At this point, I don't remember any of such story recently. So maybe I'm not sure if any one of you have heard about this. But as I remember, I suppose it can be done. I think because the best practice for this is just you should try to use the lowest possible. You should give to your container the lowest possible permission, right? Not to give it the root permission, and all the processes running in the container shouldn't use the root permission. I mean the root on the OS level. It should use the user permission. So this is the main, the first point of the Docker, let's say this best practices, I think, and this prevents from some getting out from the container, I think. So, okay, I hope I've answered your question a bit. Another questions? Okay, so just credits to the Docker guys, the Notary guys, especially for Diogo Monica from Docker Security, and he was the main, let's say, creator of the Notary thing. And that's all for you today. Thank you.
Thank you very much.